Hi everyone, welcome back for September 2024 production updates. Today we'll be talking about lots of stuff. First on our docket is the AltMill. We've continued to build and ship machines. We shipped out another 50 or so AltMills this month, or last month, and we'll be shipping out another 50 to 100 machines moving forward. There are a couple things that we've done over the last couple weeks to keep ramping up production, including building new carts and jigs for moving materials around and helping with the assembly. We've also built a bigger and more stable tapping setup so that any tap holes for the plates are being done more quickly. And we also used some of the old parts from the AltMill, our prototype AltMill, to be building that as well. There are a couple of new issues that have happened. We got another batch of rails in for the AltMill. One of the issues is that some of them were bent, which caused the machine face for the linear guides to be uneven. The good thing is that not all of the rails have been affected, so we'll be using all the good ones first, and we're working on making another batch to replace the bad ones. Those ones are expected to ship in September and arrive here in Canada probably mid-October. This shouldn't tie up any more machines, but when we do have the rails coming in or for batch 2, which is another 200 AltMills plus the bad rails. So we'll have some overlap between those two batches. The other thing that we've changed with the AltMill is that we've adjusted the microstepping settings for the Z-axis motor. Basically what happened was the way that the closed loop steppers know if a stepper has stalled is by comparing what the position of the motor is compared to how much movement it should have made, if that makes sense. So basically, if the motor is supposed to turn 60 degrees and the encoder inside says, oh, I only turned 59 degrees, then the motor will error and say, okay, I didn't travel the amount that I was being told to travel, thus the machine must have stalled. In the case with these closed loop stepper motors, this could be like fractions of hundredths of a degree. So these movements are like very, very, very small. The good thing is that with closed loop stepper systems, as soon as the machine stalls for any reason or the motors get overloaded, it will stop and it'll be able to return back to the position it started from. In the case where there's like very, very small discrepancies, it can trigger a false positive. And basically because the microstepping that we're using was really, really small, even though just those very, very small deviations from the exact point we were working at will still trigger that the motor was not in the right position. There is a window that we work within. Because of that window was too small and causing false positive, we made the window a little bit larger. And the difference is like fractions of a millimeter. In practice, it makes no difference to the user. And we're talking about like fractions of the thickness of a sheet of paper deviation, which is smaller than other things that'll cause deflection, like your bit bending, the backlash, the ball screw nuts, and things like that. So we have gotten people saying, oh, like you're making my machine less accurate. We're talking about such a small amount that for typical users that aren't spending millions of dollars on CNC machines should make no difference. And the pro of using eighth microstepping or microstepping that's smaller is that torque is typically higher on steppers the larger your microstepping is. 1/32 microstepping is still possible, but it will reduce your overall maximum torque, whereas the single step microstepping will give you the most amount of torque. There's obviously a balance in terms of choosing the microstepping. The higher the microstepping is, the smoother the motors turn because you're splitting up the step per rotation. But yeah, balance is obviously important. So yeah, if you saw Jason's video on how to update that, and if you're one of the first 50 users, you can change that. Otherwise, all the machines coming out now and after the first 50 already have that fixed, and the firmware defaults on gCenter 1.4.9 have been updated to the proper settings, so shouldn't impact anyone else, but it is something that we kind of ended up figuring out with our first small batch of users. Other things that we've been working on with the AltMill, we did also make a 2-foot by 4-foot working area AltMill because we needed another machine for testing and things like that. We also know that some people have been interested in a smaller version of the AltMill. So if you are interested in it, a 2-foot by 4-foot CNC machine, let us know, and if we get enough interest, then we may offer it as an option at some point. It isn't a big priority at this point because the 4-foot by 4-foot structure we believe is the most popular that we can make right now, primarily because it uses half sheets of what would be a 4x8 sheet, and we also get a lot of requests for a 4-foot by 8-foot working area, and we are slowly dabbling into that sort of machine size, but we're not making any promises on when that's going to happen and what the pricing and things like that are going to be. We still have a lot of work to do to get the AltMill production scaled up, and we want to be shipping enough so that we don't have a long lead time. And I expect that once we get through our second batch, we should have a much shorter lead time and have all the kinks ironed out for our production on our first batch. Batch 1 was 200 machines, batch 2 is 200 machines, so we are starting to work. We're finishing the last of our batch 1 and going into our batch 2 now, and we have about 70 machines in batch 2 accounted for, so we still have about 130 machines in batch 2 still available, and those will start production late October, early November, and we'll be working through that batch until that batch is sold out. LongMills are continuing to ship out smoothly. We haven't had any delays or issues in the recent time. No new changes for production, except we have made some updates to the T12 spring-loaded anti-backlash nut. One of the things that we found with the injection molded version was that the way that we make them is make the injection molded blank and then machine all the features afterwards, so the threading and things like that on the block. However, we found that after the machining, the internal stresses would deform the block and they would need to be machined again to fit properly. So what we ended up doing is machining the whole thing out of cast Delrin, which doesn't have the same amount of internal stresses, so that after we machine it the one time, there's no deformation afterwards. Injection molded blocks are cheaper, but when you take into account of all the extra QA and the machining that we had to do after the fact, we decided it's actually better to use the cast Delrin instead, because it makes quality more consistent and the threads better. And although the parts themselves cost a little more, it does save costs on like not having as many rejects and having more consistent quality. So we got about 300 new blocks in that have been machined, and we've been testing them, and they've worked really great. And we're working on another batch of about 1,000, 2,000 blocks, and those are being assembled now. At some point, we'll swap over them in production, probably in the next couple of weeks. Most people won't notice a difference because they'll be identical to the old and new version, so probably won't have any information on what version you're going to get because they'll be the same essentially. Yeah, the same spindle used for two different products, the LongMill spindle kit as well as the AltMill spindle kit. Guys may know those are the 1.5 kilowatt spindles that we use for both the LongMill and the AltMill. We received our first batch of 50 and shipped them out to customers, and we've received another batch of 50 in August and shipped those out as well. And we have another, I think, 250 or 350 more coming on the way that'll be arriving in the next 3 weeks roughly, and those will be used to ship out the rest of the AltMills and the LongMill spindle kits. We've allocated all of the spindles for the first 100 spindles just to AltMill kits so that we can get those out the door first. People who have ordered the LongMill kit will get those at the end of September once the next batch arrives. We did have a little bit of a shipping delay because we had accidentally asked the shipper to move it to a different port instead of the one we were supposed to, so that delayed it by a couple weeks. That's totally human mistake, but we have since resolved that, and those spindles will be arriving fairly soon. If you guys are wondering how we do the spindle testing, we do have a video on our blog and on our YouTube channel, so you can see how the testing happens, and it also covers more details on the actual true power of each spindle, router, and making those comparisons as well. What manufacturers list on spindle power may not be the same as what you will actually find in practice. And also the behavior of different spindles and different routers are going to be different. And we have a bunch of testing processes that we've developed in-house to make sure that we get a true understanding of what the performance of each cutting device looks like. Another thing that we've been working on is testing higher power spindles on the AltMill. If you guys haven't seen some of the other videos that we've put out, the limiting factor on how fast the AltMill can cut is on the spindle power. And so we've decided to test and put something super ginormous on, at least in the hobbyist space, which is the 4.5 kilowatt spindle. Daniel's thrown that on to the AltMill and did some tests, and we found that even a 4.5 kilowatt spindle is not powerful enough for the AltMill. It is super overkill for hobbyist use, and for the large majority of people, I don't expect they'll ever need such a powerful spindle. And the weight itself, the sheer weight of the actual spindle itself is pretty large. It's about 30 pounds, I think. Where this might start to apply is more for production use. Right now we kind of target the hobbyist space, but when you compare the AltMill to more production level machines, this can actually cut on par, sometimes even faster in a lot of cases than some of the industrial machines or semi-industrial machines that are out there. And once you put on the larger spindles, then we're kind of matching that sort of level of performance. You might have seen our aluminum guitar video. We found that the 2.2 kilowatt spindle that we're using on that project was still being limited by power. And so in theory, I think that project was about 12 hours long. In theory, a larger spindle, more powerful spindle will be able to cut a guitar, a giant block of aluminum, even faster than that. We also have seen a lot of comments for people wanting an ATC, an automatic tool changer. So that is another thing that we're starting to explore. Within all this spindle stuff, one of the other things that we're considering is the safety aspect of it. One of the things that we haven't seen in the industry is like a universal testing standard or a universal safety standard that people need to be able to use their spindles at home. A lot of times they are not certified. This space is still being developed. We're obviously like a relatively large player in this space now, and so we feel that we need to take more consideration into the safety, as a big spindle like a 4.5 kilowatt spindle can really do a lot of damage. We also believe that a 1.5 or even a 2.2 kilowatt spindle is going to be powerful enough for hobbyist use. However, we want to know your opinions on whether the spindle's performance is enough for your application as well. So if you have experience with using this, a spindle on your machine, there's a survey you can fill out on the blog, so make sure to check that out. And also we do ask like what sort of power you have, if you have 220 or 3-phase as well, so we can kind of get an idea on what sort of demographic we're working on. So if we do come up with new spindles, we can adapt the power that people have with the product that we come out with. Alongside that, we have the Sprouter project we're continuing to work on as well. One of the things that's really promising now is that we have the testing results for the PWM control of the Makita clone. So basically, that's like the 1.25 horsepower trim router that a lot of the LongMills and a lot of the hobbyist machines use. One of the downsides of using that system is that you have to set this dial, you have to set the speed with the dial that's on the motor. What we wanted to do is be able to also use PWM control to be able to set the speed of the router and also be able to turn it on and off with the control board. We've been working with our manufacturer to adapt a system to be able to do that and plug and play with the longboard or the super longboard, or probably with most hobby CNC controllers. And that'll be a small upgrade to what we have with the Makita currently. Just so people know, that's a brushed AC motor that has about a 1.25 horsepower and will probably be priced around $100 to $200, so around the same price as a Makita router, and that will serve as an alternative to the entry-level hobbyist CNCer. We also have the brushless DC version that we've been working on also, and that's sort of a higher power, lower noise drop-in replacement for the Makita as well. As you guys know, brushless DC motors don't have brushes, and they, in theory, last longer, and also we use better bearings for them, so they have less run out and they're more accurate overall. One of the things that we've been continuing to work on is the speed response. As the machine cuts and the load on the cutting tool changes, it also affects the speed of the motor. However, we want to be able to compensate that speed continuously so that no matter if you're loaded or unloaded, this motor is at the constant speed. The problem that we're having now is that the motors have a lot of variation in speed as the load changes, and we wanted to reduce that. And so at first we tried tuning the drivers that came with the motors, and now we're trying different drivers that are built by different manufacturers and working with them together with the motors to see if we can improve the speed control. We're also able to use censored motors, so motors that have sensors that tell what position the motor is, very similar to a closed loop stepper motor. And that in theory also will improve the accuracy of the speed response. So if you say, I want this motor to turn at 15,000 RPM, it'll stay at 15,000 RPM and not vary by much as it's cutting through material. So that's still a work in progress. We have some testing that Johan's doing. So that also is covered slightly in the video that's out right now. You can check that on the blog or on the YouTube channel. The other big thing to share is the gControl panel computer. That's going to be the panel computer we've been talking about for the last couple months. For people who don't know, that's essentially our built computer that's designed for running the LongMill or the AltMill. It's a panel computer, so you operate the machine through a touchscreen interface, very similar to a Masso controller, but we wanted it to be more open to use for lots of different applications. So it's a fully working Windows 11 computer, so you can install a browser, you can install CAM software, you can install an email client, you can install messaging services, so that if you want to, let's say, email yourself G-code files, you can do that. Or if you want to use it to watch videos, you can do that. So it's not closed to just controlling the machine. But obviously, we have gSender installed on there, and the computer is designed to be super, super reliable and super, super durable. So it's useful in a workshop application. Right now, where we are with that computer project is we've ordered 50 units to sell as like a beta testing batch. We also have been working through getting the Windows 11 licenses. So if you guys haven't been following along, basically we had two options: either use Linux, which would be free, or use Windows, which is what most people are comfortable with. We tested Linux, but we found that the performance wasn't as great, and the user friendliness, especially because most people have some experience with Windows, is lower as well. However, the cost of Windows licensing was really expensive, especially because we aren't a well-known OEM manufacturer, and we don't get the volume discounts as other large computer manufacturers, Dell, HP, Acer would sort of get. We're able to find some options in terms of buying them at bulk, but they were pretty much at retail price. So we'd have to increase the cost of the computer system a lot to be able to have those licenses available. So initially we're planning, okay, maybe we'll give it as an option where people can buy a license, or we can have people provide their own license, sometimes people may have their license already, or maybe they get a discount if they're a student or an educator. But what we found is there's another version called Windows 11 IoT, which we found would work better for this application. So for people who don't know, Windows 11 IoT is basically Windows stripped down to its basic core functionality, because the purpose of the operating system is to run for single applications. So for example, ATMs, medical devices, or aerospace use, where the computer is just designed for one use and one use only. In our case, we want to use a computer to run gSender, and gSender is connected to the machine, and in essence, that's all we really need the computer to do. However, obviously it is a fully functioning Windows 11 computer, and you can install these sort of different programs onto the computer. So it basically works as a fully fledged Windows 11 device. It just doesn't come with all the bloatware, and you can install programs onto it as you wish. The best thing is that the license is much, much cheaper, which means that we can offer it as the default option. I think the cost for the license is about $35, rather than $100 or more for the retail Windows 11 Home or Pro version, decrease the cost of the computer overall. The other good thing is that the computer is designed to be as stable as possible, which means that it doesn't get updates that change the functionality of Windows, or it doesn't change compatibility with the software already on it, and it doesn't change settings that are on the computer already. It does get security updates, and it's a secure device. We wanted to make the gControl panel computer as reliable as it could be for Sienci applications. And since there won't be any changes to the core of Windows, it means that it's not a source of problems if there's an update. Obviously, a lot of people have experienced Windows updates messing up things on their computer. That won't be the case with Windows 11 IoT. And so right now we're in the progress of getting the first 50 computers made, and we should get them mid-October. We'll be installing Windows 11 IoT on those computers and doing the testing before they get shipped out to customers. We'll probably have the order page and more information about the computer coming out in September, so keep an eye out for that. We understand the process of working with the computers as well as understanding where the interest lies for that product. We'll increase the batch size so everyone can potentially order this. I think the last thing that I think Molly asked me to include is that October 11th to 12th, we'll be in Austin, Texas to be at the Vectric user group meeting. It'll be me, Charles, Louis, and Scott. And I think, is Jason gonna be there? Yeah, Jason's gonna be there as well. I will probably be there as well. So if you are in the area, make sure to say hello. We will have some really cool prizes. We'll be giving away the AltMill that we're demoing with, as well as a couple other goodies. So yeah, if you're there, make sure to check us out. The Vortex continues to ship out as usual. The LaserBeam also continues to ship out as usual. We are coming up with the closed loop system for the Vortex, which means that pretty soon you'll be able to use all 4 axes simultaneously. Basically what we're doing is putting the closed loop stepper, connecting it to the SLB, and also if you want to use closed loop stepper mode, you do need the SLB. And basically you can move the X, Y, Z direction all simultaneously while the A axis is moving. Traditionally, the original version of the Vortex needed you to lock the Y axis in place and use the motor power coming from that to do the A axis. Although like for most use, everything will be the same. However, once we get into more advanced 4-axis programming, you'll be able to do some more complex carving as well. That's still a work in progress. We're getting the hardware in for that and setting up the kits and doing the testing for it. Share that very soon also. We're working on, we do have the order options now. We will have a blog article that covers all the differences between the 2 versions. People will also be able to upgrade their Vortex with the open loop stepper into a closed loop stepper. So they'll be able to get all the functionality without having to buy a whole new system. So yeah, keep an eye out for that. That's all the updates for September. Thanks for watching. We'll see you in the next production update, and make sure to check out the blog because we'll have more information and pictures and all that cool stuff there. Bye.